Good afternoon, my dear students. Today we'll discuss about mutual induction. Mutual induction topic. Today's topic is mutual induction. Mutual induction we will need two coils. First coil second coil. First coil is connected to a battery. The second coil is the battery. Second coil is connected to a galvanometer. First coil current. A current I1 is passed in the first coil. When the current is passed in the first coil, first coil will produce a magnetic field. Magnetic field this magnetic field is B1. Ahanba coil the current a magnetic field is produced by the first coil. This magnetic field B1. This magnetic field is called B1. This magnetic field B1 is aniswa coil. Aniswa second coil first coil second coil is placed very close to the first coil so that first coil na putoiba magnetic field second coil the foul. So solenoid in case of solenoid magnetic field की value is mu naught n I लेरेको. Where n is the number of turns per unit length. Here we have two coils which are very close together. Current a current is passed. Current means I1. A current is passed in the first coil. It will produce a magnetic field B1. This magnetic field B1 is passed through the second coil. So step 1 current magnetic field B1 is produced. Second coil will come to the second coil. Second coil magnetic field. This magnetic field B1 is a top current I2. Another current is produced in the second coil by the magnetic field. Overall step current magnetic field B1 first coil. The second coil magnetic field current just opposite reaction reverse reaction this process is called mutual induction. Definition is whenever there is a change of current in a coil and EMF is induced in a nearby coil, this process is called mutual induction. Coil that has a level current to cariguma home Sina Karibudoki changing magnetic field. Changing magnetic field a top coil the current amamuk process mutual induction. So overall the changing current produce a changing magnetic field. Changing magnetic field produce a changing current. Overall view. So current magnetic field the magnetic field is current process. This process is called mutual induction. Welcome to the next page. Expression for induced EMF. Mutual induction induced EMF. So let me draw this situation. So first coil, coil 1. Here we have another coil. This coil is called coil 2. So first coil is the current I1. I1 is passed in the first coil. Then it produces a magnetic field B1. See, magnetic field also passes through the second coil. See, magnetic field in the second coil the EMF. Second coil the EMF B2. B2 is the EMF produced by changing magnetic field. EMF current I2 coil the same current I1 and coil the same current I2 and coil the puthropo potential difference na V2 na hai se sigi V2 is niko EMF induced in the second coil is directly proportional to rate of change of current in the first coil na de EMF induced in the second coil have niko is directly proportional to rate of change of current in the first coil. Then we'll write V2 is equal to minus the constant ma half like proportionality is equal to the on top of the constant ma half to niko see constant see means M chorus here M is called mutual inductance guys. M is a constant called mutual inductance. Here is the definition of mutual inductance. So B2 is equal to minus M di by dt. The mutual inductance is the EMF induced when the rate of change of 1. If the rate of change of current I1 represent in the first coil, if the rate of change of current in the first coil is 1, then EMF induced is called mutual inductance. It's the period definition. B2 is a minus M di1 by dt level. It's the rate of change of current in the first coil level. Rate of change of current to first coil the rate of change of current to 1 over d. So M is induced EMF mutual inductance is the EMF induced. So mutual inductance is the EMF induced in the second coil by a unit rate of change of current in the first coil. तो मागे unit से SI unit of M is Henry को. This is called Henry. SI unit of mutual inductance. Next page we'll come to the next page. So relation between magnetic flux and the mutual inductance बनेगा. So relation between flux, magnetic flux का mutual inductance का M is equal to phi 2 by I1. Where phi 2 is the second coil, the power flux where phi 2 is the flux passing through the second coil A2 N2. Second coil the power flux phi 2 is banana BAN. B is the magnetic field produced by the first coil. I1 is the current pass in the first coil. See let me draw once more this section. Here is the first coil. Here is the second coil. Coil ani so first coil the current I1. See is the second coil. A current is passed in the first coil. Current thousand bagamana puthoropo magnetic field though B1 B1 is a magnetic field produced by the first coil. It also passes through the second coil. B1 is the first coil. B1 is produced by the first coil. First coil की पुथरोपो magnetic field though second coil arrangement is made in such a way that B1 also passes through the second coil. Second coil की number of turns N2. Second coil the power of magnetic field is na B1. See area of cross section से कोई ना A2 लोग दोई निको. For the second coil second coil की area of cross section A2, number of turns N2. तो उससे power plug magnetic field is na B1 B1 is the magnetic field passing through the second coil. So the flux to the flux passing through any coil. Flux passing through the second coil. First that's minus BAN hana iroko. So power of magnetic field is B1. Magi area is A2. Number of turns N2 lays. Total flux passing through the second coil. The ani mutual inductance was flux divided by current. Flux mutual inductance of these two coils. Flux passing through the second coil I1 is 1000 current. I1 is the current passed in the first coil. Because the B1 is the for this solenoid B1 की value से क्या लगी वो mu naught N1 I1 ले रहे से where N1 is number of turns divided by length. So these are some mutual inductance that दरकार लेवा points required in mutual inductions. So let us find solenoid. Next example. So we will find mutual inductance of a pair of long coaxial solenoids. Mutual inductance of a pair of long coaxial solenoids. So in coil number 1, it is made larger as compared to coil number 2. Coil 1 is coil number 2. 2 से 1 से की मनूंग धाप से लगते हैं overall figure से ले रहे से इसे larger coil से की मनूंग the smaller coil तो हाफ से लग पनेगा and our aim से कहना वो to find mutual inductance of this system से की system से की mutual inductance बताते हैं we'll find mutual inductance देखो of this pair of systems. So steps required था चिन्ह coil आहान larger coil से smaller coil देखो larger coil देखो ना current I1 था चले will come to see mutual inductance की formula से आना है तो E रोसे first कोई ना E तो phi 2 divided by चले तो I1 लगेगा और यार phi 2 से कोई ना B1 बनना है अपने को B1 A2 N2 divided by I1 B1 तो दी magnetic field produced by first coil is E क्या बताओ mu naught N1 I1 सिना B1 की फॉर्मूला निकालो A2 N2 divided by I1 so कोई ना I1 का कैंसिल तो देखो तो चलिए हम और इसे mu नो ले देखो N1 से you can write N1 divided by L A2 so mu नो ले देखो N1 ले I का खे N1 से number of turns divided by length A2 N2 final answer is mu naught N1 N2 A2 divided by L. So this is the mutual inductance of this pair of coaxial solenoids. So here is a full expression to page number 4 the I'm gonna page number 4 the so now we'll solve one NCERT exercise 6.9. A pair of adjacent coils has a mutual inductance of given things go. So let's see coil 0 mutual inductance is 1.5 Henry. If the current in one coil changes from 0 to 20 ampere change in current is equal to 20 ampere time for changing current is 0.5 second. Then what is the change in flux? Mutual inductance current time period. What is the change in flux? So to solve this problem first so EMF induce M delta change in current divided by time. So EMF induced is also equal to B is M di by dt. Flux change in flux divided by time go m delta I by t. So t is makasis. The change in flux is equal to m into change in current. So m की value is 1.5, change in current is 20 p. So here is a calculation. M 1.5, the change in current 20. Answer is not 20 Weber. Our answer will be 20 Weber. So mathangi topic next will come to ED current. ED current. So is a North Pole, South Pole magnet niko. This is a magnet consisting of North Pole and the South Pole. So marak sida magnetic field. There is a magnetic field in between this North Pole and the South Pole. So when a metal plate vibrate, a metal plate is allowed to vibrate in this magnetic field. So magnetic field is manung the metal plate vibrate nigo. So when a metallic plate vibrates inside a magnetic field, see manung the circular current. Suppose this is the metallic plate. Metallic plate, see manung the circular currents are induced. See metallic plate. When this metallic plate vibrates inside a magnetic field, circular currents are induced. See circular currents. These are called ED currents. So ED current means circular currents induced in a metallic block when the magnetic field passing through the block is changed. So metallic block the power of a magnetic field. If the magnetic field passing through a metallic block is changed, circular currents are induced. These circular currents are called ED currents. See, ED currents are produced by electromagnetic induction. So, relative change within the magnetic field and the metallic block. So, current, ED current, it is produced by electromagnetic induction. So, because of this ED current will produce unwanted heat. See, metallic block will become very hot due to the production of this ED current. ED current metallic blocks heat will be produced from this metallic block. Then next the question will go, how can this ED currents be minimized? Metallic block that's ED current tholani aduga metallic block to sagalalnganeba. Durga disi ED current to kamina minimize to gudege buchi metallic block to gena smana macet kakto. And this metallic blocks laminated to is cut into pieces. So this is circular current generated large circular current to be generated to cut by the pieces. So this the current se minimized to be so when the question number 2, 3, the last page. In the last page we have uses of ED current. So the headings ED currents are used in magnetic braking in trains, electromagnetic damping, induction furnace, electric power meter. See writings na PDF, the PDF periods dito ni So see, so with this topic, electromagnetic induction is portion the lower. From the next class we'll do alternating current. Matangi class ta alternating current horani ko. Sibuk the induction ki tabag lore. Solution logic.